Hello, this is Dr. Hanaa Assil, and these are questions and answers on organic nitrogen compounds. So we will be talking about amines, amides, amino acids, and proteins. So let's take a look at some questions. This is from Unit 5 of the A2 Chemistry Edexcel questions. So the first question here is talking about which of these is the weakest base. Well, all of these are ammonia or amines, and we should know that ammonia or an amine are in general bases. But which of these is the weakest base? Well, the strength of the base depends on the availability of the lone pair of electrons on the nitrogen atom to bond with an H+ ion. So, for example, if we're talking about ammonia, ammonia is something that has 3 hydrogens. It has lone pair of electrons on the nitrogen that can be used to make a dative bond with an H+ ion, and that is why we say ammonia is a base. So, what about butylamine or ethylamine? Well, you should realize that amines are derivatives of ammonia, so we remove one of the hydrogens and put an alkyl group or a benzene ring. And we should know that alkyl groups means carbons and hydrogens, like the butyl group or ethyl group. Alkyl groups are what we call electron donating. And the longer the alkyl group, the more carbons and hydrogens attached to the nitrogen, the more electron donating. And when it is electron donating, that means that the lone pair of electrons on the nitrogen are available to make dative bonds with the H+ ions. Which one is more basic? Butylamine has a longer alkyl group. So butylamine is a stronger base than ethylamine, and ethylamine is a stronger base than ammonia. But what about phenylamine? Phenylamine is basically a benzene ring with an amine group, NH2. But in this case, the lone pair of electrons on the NH2 are used to delocalize with the pi bonds of the benzene ring. We know that in the benzene ring we have pi electrons, pi bonds that are delocalized around the carbon atoms. Well, if we have an amine group that has a lone pair of electrons, then these lone pair of electrons are delocalized around the benzene ring so that they're not available to make a dative bond with the H+ ion. So actually, compared to the others, phenylamine is a weaker base than ammonia, and ammonia is weaker than an alkyl amine. So if we say separate 0.1 mole per decimeter cubed aqueous solutions of ammonia, butylamine, and phenylamine were prepared, which of the following sequences shows the solutions in order of increasing pH? And you should realize increasing pH means more and more basic. So which of these are arranged in order of increasing pH? We said the phenylamine would be less basic than ammonia, and then the alkyl amine like butylamine is the most basic in these choices. So if we have a question like this, explain why phenylamine is a weaker base than ammonia. We said this is because in the ammonia, the lone pair of electrons are available to make a dative bond with the H+, but in the benzene ring, one of the p orbitals on the nitrogen atom in the phenylamine overlaps with the pi bonding system in the benzene ring. So this causes the lone pair of electrons on the nitrogen atom in the phenylamine to be delocalized into the benzene ring, so it is less available to form a dative bond or a coordinate bond with an H+ ion than in the case of ammonia, and that is why phenylamine is a weaker base than ammonia. Are we following? Okay, what about this question? Explain by considering both nitrogen atoms in this molecule, which he calls procane, which nitrogen is more likely to be protonated in the reaction with hydrochloric acid. So if I react this with an H+ ion, which of them has more lone pair of electrons available to bond with an H+ ions? Of course, you can see that the nitrogen of the amine bonded to ethyl groups is more likely to be protonated, and this is because the ethyl groups are, we said, they are called electron donating. So the lone pair of electrons on the nitrogen are available to form a dative bond with the H+ ion, while the nitrogen on the benzene ring, the amine on the benzene ring, has its one pair of electrons delocalized on the benzene ring. So they are less likely to attack an H+ ion. Okay? Okay, let's go into something else. What is the name of this compound? Well, first of all, you should realize that we have amines where the nitrogen is bonded to alkyl groups or hydrogens. The amide group is the one in which we have a C double bond O NH2, and the amino acid is a compound in which the carbon is bonded to a carboxylic group and to an amine group. So which kind of compound is this? Well, obviously this is an amide. Now, how do we name the amide? We can see that the C double bond O NH2, that's the first carbon. So that will be carbon number 1. We have a total of 4 carbons in the chain. So this would be something butanamide. Okay, it will be what butanamide? Well, I have a methyl group on carbon number 2. So this is 2-methyl butanamide. The structure of the amino acid isoleucine is shown. What is the systematic name of isoleucine? How would you name this? Well, let's see. The longest chain, starting with the C double bond O as carbon number 1. And we have the NH2, which we call an amino group on carbon number 2. So this is 2-amino, 3-methyl pentanoic acid. Can we see that? Okay. We have this compound and he's saying name the 3 functional groups present in this compound. Well, let's see. What is in this compound? We have an ester. Can you see where the ester is? That's the C double bond OO something. So that's the ester group on the right. And we have an amine. That's the NH2 on the left. And the benzene ring you can refer to as benzene or an arene group. What is the structure of isoleucine in a solution of pH 2? We should realize that this is an amino acids, and amino acids have different structures whether we have an acid medium or neutral medium or a basic medium. So if we put any amino acid in water at neutral pH, it is in the form of what we call as Zwitter ions. Zwitter ion means the the amine part is in the form of NH3 plus and the acid part is in the form of COO minus. That's in neutral pH. Now what if we put it in pH 2? pH 2 of course is acid, low pH. Now in low pH, the acid part, COO minus, becomes COOH. And if we put a base in this medium, then we have the NH2 is now just NH2, not NH3 plus, and the acid part is a COO minus. Can we remember that? So this has to do with amino acids because they have an amine group and an acid group. So we said if we put this compound isoleucine in a solution of pH 2, so we're putting it in low pH, in acid, then the NH3 is in the form of NH3 plus, and the acid is COOH. Okay, this question says which structure best represents alanine at high pH? So we said at high pH, that means I'm having a base somewhere, so this amino acid would exist in the form in which the NH2 is as it is, but the COO part is in the form of COO minus. So this is the form of the amino acid at high pH. Alanine is a crystalline solid at room temperature. What are the main forces broken when alanine melts? We have to remember that alanine are simple molecular structures, so they would have London forces. They also have hydrogen bonds, and they have covalent bonds inside their molecules, but when they melt, the bonds that are broken are the ionic bonds, because remember that the amino acids have an acid part that will exist in the form of COO minus and an amine part that could exist in the form of NH3 plus. So there would be ionic bonds between the molecules, and these are the strongest bonds that are being broken when an amino acid melts. Hydrogen bonds are formed when methylamine dissolves in water. Which structure best represents a hydrogen bond between methylamine and water? You should remember that hydrogen bonds are formed if we have a hydrogen bonded to an electronegative element. So the hydrogen of one molecule is attracted to the electronegative element of the other molecule, and the bond has to be a straight bond in which the angle around the hydrogen is 180. So remember, if we have an amine, amines are miscible with water. They dissolve in water. And why do they dissolve in water? Because they can form hydrogen bonds with water, and this is the kind of hydrogen bond. Of course, the hydrogen has to be bonded to one electronegative element and attracted to another electronegative element. So these are the forms of hydrogen bonds that we can form. What is the systematic name of this compound? Well, let's take a look. This is a benzene with amine groups and a methyl group on it. So how are we going to name it? Well, let's start with one of the amines, and remember that we need to go around the benzene ring so that the substituents have the lowest number. So the carbons having these substituents must have the lowest number. So if we start with the NH2 at the bottom and go around so that the other amine is on carbon number 3 and the methyl group is on carbon number 4, then the name of this is 4-methyl benzene 1,3-diamine. Draw the structure of the organic compound formed when hydrochloric acid is added to phenylalanine. So we want to draw what? We have phenylalanine, that's the amino acid, and I'm adding acid to it. And we said when we add acid to an amino acid, then the NH part becomes NH3 plus, and the acid part is COOH. So this is the structure formed when phenylalanine is in acidic medium. What is the organic species formed in the reaction between this compound and excess ethanoyl chloride? You should know that amines react with ethanoyl chloride. This is the structure of ethanoyl chloride. Amines will react with ethanol chloride so that the NH2 part becomes NHCOCH3. And if we have excess ethanol chloride, then both amines will become NHCOCH3. This is how we add a group to the amines. Again, if I start with nitrobenzene, how can I put an amine group on benzene? So I'm starting with nitrobenzene. I want to change it into phenylamine. You should remember that to change a nitro on a benzene to NH2 on a benzene, I put tin and concentrated hydrochloric acid. Tin, SN, and concentrated hydrochloric acid, we change NO2 on a benzene ring to NH2. And this is how we prepare aromatic amine groups from a nitro group. Which is the reagent for step 4? Well, what are we doing in step 4? We have the group that has the double bond OCl. This is an acyl chloride, and I'm changing it into an amide. And you should remember that acyl chlorides, when they react with amines, then they form amides. And this is how we prepare an amide. So what should we react with this first reactant? We need to react this part. We need to add this part so that it replaces the chlorine on the acyl chloride. So this part is this kind of amine. This is the reagent that we need. So which of these is the correct structural formula for that? Well, if you look at this, this is the answer where we're looking from the right, CH3, CH, NH2, CH2, CH3. So that is the compound that we need to react with the acyl chloride to form that amide. Phenylamine reacts rapidly with dilute sulfuric acid. This reaction is what type? Well, phenylamine is an amine, and when we react it with an acid, it forms a salt, ammonium salt, plus water, acid plus base to give salt plus water. That is a neutralization reaction. Draw the structure of the organic product formed when excess sodium hydroxide is added to aspartic acid. Again, if I add a base to an amino acid, we said the acid part will become, instead of OH, it will become the sodium salt. So we have O minus Na plus on each of the OHs of the acid. When dilute hydrochloric acid is added to butylamine and the solution is allowed to evaporate to dryness, a white solid forms. What is the formula of the white solid? So what are we adding? We're adding butylamine plus hydrochloric acid, and what we get is the butyl ammonium chloride, and that forms a white solid. 4 amino acids are dissolved in deionized water. Which amino acid will give the solution with the lowest pH? Lowest pH means which of these is most acidic? Well, the one that is most acidic is the one that will have more acid groups. So obviously this one has 2 acid groups. The others all have only 1 acidic group. So this would be the one with the lowest pH. Okay, what about this one? Deduce the classification of the labeled amine group. What type of amine is that? Remember, we have something called a primary amine, secondary amine, tertiary amine. Now, you should know that all of them are derivatives of ammonia. If I remove one of the H's of ammonia and replace it with an alkyl group, so that R there represents carbon, carbon, carbon chain, whatever. So I put one alkyl group on the ammonia, that's a primary amine. So a primary amine is nitrogen with 2 hydrogens and then it's attached to something. A secondary amine is a nitrogen that has 1 hydrogen and it's attached to 2 alkyl groups. A tertiary amine is the one that in which all the hydrogens of the ammonia have been replaced. So that one up there is which type? Obviously, this is a nitrogen that doesn't have any hydrogen anymore, so this is a tertiary amine. Amines can be prepared by reduction of nitriles. Identify the nitrile and the reducing agent used to prepare what? We're trying to prepare butyl amine. So, butyl amine starting from a nitrile. Remember that the nitrile is the C triple bond N. So, if I want to end up with butyl amine, then I'm going to start with the nitrile attached to 3 other carbons so that it has a total of 4 carbons. So this is butane nitrile or butyl nitrile. Now, in order to change butane nitrile or butyl nitrile into butyl amine, what should I use? I should use lithium aluminium hydride or hydrogen in presence of nickel. Remember that that is the same as lithium tetrahydroiodoaluminate, LiAlH4. Which amine could not be prepared by the reduction of a nitrile? Well, the nitrile has to be something in which the carbon at the end is bonded 3 bonds to nitrogen. So A can be made from a nitrile in which you're going to reduce this nitrile, it will give the amine. If I have this nitrile, it would give C. If I have this nitrile, it can give D, but I cannot prepare the structure in B from a nitrile because it needs a carbon that already has 2 groups attached to it, and that means you cannot have triple bond N at that carbon. So this question says, which reaction can form a secondary amine? Let's take a look at these reactions. That first reaction is a nitrile or a cyanide with lithium aluminium hydride. That will change it into this kind of amine, and you should realize that this kind of amine is a primary amine in which the nitrogen has 2 hydrogens attached to it. Now, in choice B, we have ethyl amine reacting with ethyl bromide. So this is a method of putting a new ethyl group on the nitrogen. So now the nitrogen has only 1 hydrogen and 2 R groups. So this is a secondary. So this is the one we're looking for, secondary amine. Now, this one is a nitrogen in C. It's a nitrogen that already has 2 alkyl groups, and I'm reacting it with another alkyl halide that puts 3 alkyl groups. So this is a tertiary amine. And this last one, we have an amide with sodium hydroxide. Remember, this would be alkaline hydrolysis of the amide. So that would break that bond to form the sodium salt and an amine. And that amine that is formed there is also a primary. So our answer was B. This question says, which ion is formed when a mixture of sodium nitrite and dilute hydrochloric acid reacts with phenylamine at a temperature of 5 degrees Celsius? Remember, if you have an amine, phenylamine, and you react it with sodium nitrite in presence of dilute HCl at 5 degrees Celsius, this is a method of changing the phenylamine into a diazonium salt. Remember, the diazonium salt is something that has N triple bond N, and there is a positive charge on which nitrogen? On the nitrogen that has 4 bonds attached to it, 3 to the N and another one to another group on the other side. So that is our diazonium salt. The question says 3-amino-benzoic acid reacts with sodium nitrite and dilute hydrochloric acid, forming a diazonium ion. Again, this is when I have an amine, I put sodium nitrite and HCl and it forms a diazonium ion. And the question says state a temperature at which this reaction should take place, given one reason for your answer. Remember, we said the temperature should be somewhere below 10 degrees Celsius. We usually say 5 degrees by using ice. This is because the diazonium salt that is formed is unstable. It decomposes easily at higher temperatures to give nitrogen gas, so we don't want that to happen. We keep the temperature below 10 degrees Celsius. What is an organic product of the reaction between ethylamine and chloroethane? Where is ethylamine? This is ethylamine with chloroethane. Remember, this is a method of adding the alkyl group to the nitrogen. So this will form this kind of product. So this is our choice. Remember, an amine with an alkyl halide will add the alkyl group to the nitrogen atom. The compound pyridine is used in the synthesis of chlorpheniramine, something. Like many amines, pyridine is miscible with water and the solution formed is alkaline. Explain each of these properties of pyridine. Again, something that has an amine in it is miscible with water. Why is it miscible with water? Because we said it can form hydrogen bonds with water, and when it forms hydrogen bond with water, it forms the ammonium salt plus hydroxide ion. So it is miscible with water because the lone pair of electrons on the nitrogen atom forms hydrogen bonds to water. It can form dative bond with H plus from water to form OH minus, which causes the solution to be alkaline. So it's sort of breaking up the water into H plus and OH minus when we dissolve it in water, and that gives an alkaline solution. A student suggested that the final step in the synthesis of this compound starts with the reaction between these two initial compounds given. Assuming the reaction is similar to that between ammonia and chloromethane, complete the mechanism for this proposed reaction. So we have basically an amine and we're reacting it with chloromethane. How does this reaction proceed? Remember, the nitrogen has lone pair of electrons, so this attacks the slightly positive carbon, and the electrons of the bond between carbon and Cl will go to the slightly negative chlorine. So this is the kind of intermediate we have, and then the electrons from the H goes to the N plus, so that we get the final product. This question says I'm starting with aniline, so this is a phenylamine actually that has a benzene with an amine group on it, and we're changing it into this other compound. What would be our reagent? Remember, to prepare this from phenylamine, I am adding this group to the amine, so I will be reacting it with this kind of compound. This kind of compound is called ethanoyl chloride. Remember, we need to put a group on the nitrogen of the amine. We react it with ethanoyl chloride. Give the structure of the organic product of each of the following reactions of this compound by hydrolysis with excess sodium hydroxide. So if I react this compound with excess sodium hydroxide, that will break up this ester linkage, and I will get the sodium salt of the C double bond OO and the alcohol that should be formed would actually be in the form of O minus Na plus. Remember, hydrolysis of esters like C double bond O or something, this would give the acid part, which is the C double bond OO, and the alcohol part. But if we have in presence of sodium hydroxide, then it is the sodium salt. What if we do this reaction with condensation with ethanoyl chloride? Now, if I have that compound on top and I react it with ethanoyl chloride, remember we said that is how we put that group on the nitrogen of the amine part. So ethanoyl chloride would put the C double bond O CH3 group on the nitrogen. A reaction scheme for preparation of an azo dye is shown. And the questions are, question 1 says, step 1 takes place using a mixture of concentrated nitric and concentrated sulfuric at 55 degrees Celsius. This is how we put a nitro group on the benzene ring. And the question is, why is the reaction not carried out at a higher temperature? Remember, if we have concentrated nitric and concentrated sulfuric, it puts NO2 on the benzene ring. But if I heat it to a very high temperature, then it can put several NO2s on the benzene ring. So we don't do it at a higher temperature to prevent further substitution by a nitro group that would occur if we heated it to a higher temperature. How is step 2 carried out? This is step 2. We said nitro benzene to phenylamine. We change the nitro group to NH2 by reacting with tin in presence of concentrated HCl. Then sodium hydroxide is added at the end. Remember, it is tin and concentrated HCl. Step 3, which is shown here, takes place using sodium nitrite and dilute hydrochloric acid at 5 degrees Celsius. Remember, sodium nitrite, dilute hydrochloric acid at 5 degrees Celsius, this changes the amino group into the diazonium salt. So what does the diazonium salt look like? We said this is N triple bond N, and the positive is on the nitrogen in the middle that has 4 bonds attached to it. Then the diazonium salt in step 4 goes to azo dye. What condition is needed for this reaction? If I'm trying to prepare the azo dye, that means I'm going to react the diazonium salt with phenol. And this is in alkaline conditions. Remember, we react the phenol with the diazonium salt in presence of sodium hydroxide in order to attach that benzene with an OH to the diazonium salt. This happens in alkaline conditions. Nitrobenzene can be converted into phenylamine, which is a liquid under normal laboratory conditions. Again, we said, how do we change nitro to amino? We said nitro to an amino group on the benzene ring. This is in presence of tin in concentrated HCl. Then the question says, which technique is used to separate phenylamine from the reaction mixture? If I'm trying to separate phenylamine from the reaction mixture, then we use what we call steam distillation. And steam distillation is a method of heating the reactants. Can you see the flask that has the reactants? We don't want to heat it to a very high temperature. So what we do is we heat the water in the previous conical flask. The water changes into steam. The steam passes over the flask and the reactants in the flask. So this helps to heat the reactants so that they evaporate and then are cooled and condensed in the condenser without their decomposition. So the reactants are not heated to a very high temperature so that they do not decompose on heat. Draw the structure of the azo dye formed when the diazonium ion reacts with phenol. So we're trying to react this with phenol, and we said what happens is we add the phenol at carbon number 4 of the phenol. So this is a para addition from the hydroxyl group. If we say the hydroxyl group on the phenol is carbon number 1, we're going to attach the diazonium salt at carbon number 4. Reaction of phenylamine first with ice-cold nitrous acid and second with an aromatic organic compound gave a yellow precipitate with this structure. The aromatic organic compound added in the second step was which one? So what did we add to the diazonium salt? We added this part. So this is which choice? This is this one. That's what we react with the diazonium salt in order to get that product. Azoviolet is used as a dye and an indicator. A synthesis of azoviolet from 1 amino, 4-nitrobenzene is shown. Give the reagents and conditions for step 1. Again, how do we change amine into diazonium salt? We said we add sodium nitrite, HCl, dilute HCl at 5 degrees Celsius. Deduce the structure of the organic compound needed to produce that final azo dye. Again, what should I react with the diazonium salt in the middle in order to get that product, the azoviolet? Well, what part are we adding? We're adding this part, then that means I'm reacting it with this compound. Okay. Compound X reacts with excess nitrous acid followed by coupling with excess phenol to form an azo dye. What is the structure of the azo dye? So if I have compound X and I add excess nitrous acid, remember that nitrous acid does what? Nitrous acid is sodium nitrite with HCl, and this gives the diazonium salt. We're using excess, and that means both amine groups on both ends of the molecule will change into a diazonium salt. And then we're saying we'll react it with phenol, and of course with phenol, then you're adding the phenol part to each of the nitrogen. So which product do we have? You can see that that is the same as the product in D. And we'll stop here for now, and this is the first part of these questions, and we'll have a second part. Please keep listening, and thank you.